You know that feeling, right? You're cruising down a perfectly good road, and suddenly, bam, you hit a massive patch of fresh, sticky black tar, and a loose layer of gravel just starts pinging relentlessly against your car. It is, frankly, a universally relatable annoyance. But what if I told you that this seemingly messy, frustrating inconvenience is actually a highly calibrated, billion-dollar engineering secret?
Well, welcome to the Explainer. Today, we are completely changing how you look at road maintenance. We're going to explore the fascinating science of Chipseal and learn how what looks to us like a rough, dusty patch job is in reality highly precise, preventative medicine for our global infrastructure.
All right, so here's our roadmap for today. We'll kick things off with a road repair dilemma, then meet the Chipseal itself. After that, we'll break down the ingredients for a perfect seal, walk through the actual application process, and wrap up with exactly why this matters so much to our daily lives. Let's get into it.
Starting with Section 1, the road repair dilemma. Okay, so roads are constantly taking a beating, right? From heavy traffic, harsh weather, and invisible chemical changes deep inside the asphalt itself. And that brings us to a brilliant piece of insight regarding pavement preservation. The idea is to treat a road while it's still in decent shape. It's literally just like painting a wooden house. You wouldn't wait for the wood to completely rot and the frame to collapse before breaking out the paint, would you? No way! You paint it early to stop the weather from causing rot in the first place. With roads, it's exactly the same concept. It's all about making a small, smart investment right now to avoid a massive, expensive structural failure later.
Moving on to Section 2, meet the Chipseal. So, the hero of our story is something formally called surface dressing, though you probably noticed Chipseal. It's an extremely economical surface treatment, but here's the kicker. It doesn't actually provide structural improvement. Like, it's not going to magically fix a sunken, caved-in road. Instead, its job is to act as a tough, waterproofing shield and a friction enhancer. It totally protects the crucial structural layers underneath from water intrusion and everyday wear and tear.
Which brings us to Section 3, ingredients for perfect seals.
To make this waterproof shield actually work, engineers can't just toss down random rocks and hope for the best. They have to perfectly match two vital ingredients, kind of like a master chef following an incredibly strict recipe. First, you've got the binder. This acts as the flexible, water-resistant glue, and it can be made of bitumen emulsion, hot binder, or a cutback. Then, contrasting directly with that liquid base, you have the hard protective armor, the aggregate. These are typically 6 to 12 millimeter crushed stone chippings.
It is honestly fascinating to see these two distinct elements in action. You have the dark, heavy liquid bitumen spraying out onto the pavement, paired right alongside those highly specific, uniform rock chips that are just waiting to be embedded into it. It really perfectly visualizes that glue and armor concept we were just talking about.
But those stones, they are definitely not just random gravel scooped out of a nearby quarry. Oh no, they have to meet absolutely incredible engineering constraints. Take dust, for example. Engineers require minimal dust. Specifically, less than 2% can pass through a tiny 200 mesh sieve. Why so strict? Because too much dust completely ruins the adhesion. It acts exactly like throwing flour onto a sticky surface. Plus, the stones need a low flakiness index because flat, flaky stones simply won't interlock properly under heavy traffic. They need to be strong, uniform, one-sized cubical fragments to do their job right.
All right, Section 4, the application process. Let's see how this all comes together.
The whole process is essentially a highly coordinated construction dance where timing is literally everything. Step 1, you meticulously prepare and clean the old road's surface. Step 2, spray the binder completely evenly. Step 3, spread the aggregate almost immediately. Step 4, roll and compact the chips down. And finally, Step 5, sweep up all those excess loose rocks the next morning once the whole thing cures.
Let's look a bit closer at that second step. This specialized pressure distributor is laying down the exact right amount of emulsion. It uses specially arranged nozzles to ensure full, perfectly even coverage with absolutely zero runoff. And get this, they are applying this emulsion hot. We're talking temperatures strictly controlled between 65 and 90 degrees Celsius.
Then, almost instantly, the chip spreader follows right behind it. It's dropping that clean, perfectly graded aggregate directly into the hot, curing binder before the liquid even has a chance to set and lose its stickiness. It's a total race against the clock.
Finally, they bring in the heavy hitters, pneumatic tire rollers. These machines make 4 to 5 continuous passes over the fresh stones to properly align and embed the chips deeply into the binder.
This vital step firmly locks the new surface into place way before everyday traffic is allowed anywhere near it.
Now keep in mind, this is definitely not a one-size-fits-all operation. Depending on the environment, engineers use highly specific variations of this process. For instance, the Chipseal uses a wider range of aggregate sizes and a softer binder, which makes it highly flexible and absolutely perfect for colder climates. Or take the Chipseal, where the binder is literally broomed into the road surface. That forces the liquid deep down into existing cracks before the aggregate is even applied.
And finally, Section 5, Why Pavement Preservation Matters, which really answers the big question, why should we put up with this temporary mess on our morning commute?
Well, the answer is genuinely staggering. According to transportation departments, like the Michigan DOT, for example, for every single taxpayer dollar spent on this preventative maintenance today, we save a massive $6 to $10 on future reconstruction. I mean, come on, that is just an incredible return on investment.
And beyond those huge cost savings, surface dressing provides some really fantastic safety and environmental benefits too. It restores vital wet weather skid resistance, it stops the oxidative aging of the asphalt dead in its tracks, and it keeps traffic delays to an absolute minimum compared to ripping up and entirely rebuilding a road. Plus, modern environmentally friendly polymer options can even be mixed right into the emulsion. This drastically reduces the project's carbon footprint, completely skipping the toxic fumes you get from older hot binders.
So, I really hope this explainer has totally shifted your perspective, leaving you with a newfound appreciation for the billion-dollar engineering secret hiding right beneath your tires. What looks to us like a dusty mess is actually keeping our world moving smoothly and saving billions of dollars. So the next time you hear those loose chips pinging off your car, ask yourself, what other everyday annoyances might actually be invisible engineering marvels?